Kia ora team. So this is the 2022 maths exam from Western Heights High School. Today in this video we're going to have a look at answers to as many of those questions as we can. We're going to look at which ones we got right, which ones we got wrong, and if so, why we got them wrong, so we can learn for next time. Okay, let's get into it. Now this was a 90 question exam done over 2 hours. We used calculators for these. Each question was worth a mark, unless stated otherwise. There were key parts where you were only rewarded the mark if you showed working. Now, some of the questions may appear harder than others. We tried to make it so that the easier ones were at the front, but you'll come across easy ones throughout as well as hard ones throughout. One of the key skills is making sure that we don't get overwhelmed as soon as we see something that's a little bit tough and then give up. We want to keep going regardless. So let's have a little bit of a look. All right, first question. List the first 5 multiples of 8. So for there, we're talking about 8 times 1, and 8 times 2, and 8 times 3, and 8 times 4, and 8 times 5. So if we skip counting 8s, we go 8, 16, 24, 32, and 40. Some of us got a little bit confused between the word multiples and the word factors. That's okay if we made that error. We're just going to make sure we improve that for next time. Right, for our second question, we've got 15x plus 8x minus 2x. If I said you had 15 bananas plus 8 bananas, take away 2, you'd know you had 21 bananas. It's the same with x's here. We're grouping like terms. So here overall, we have 21 x's. Here, we have a little geometry question. We've got some vertically opposite sides, vertically opposite angles. So we know that this angle is going to be the same as this whole angle here. But this whole angle has been cut into 2 chunks. One chunk is 23 degrees, and the other chunk we don't know. We're going to try and figure it out. Well, we know that the whole thing is going to add to 41. So 41 take away 23 is going to give us x, which is 18. And that's the rule written in shorthand form. Now we're on to a rounding question. When we're rounding, we count the number of figures we want. Here we want 3, so we go 1, 2, 3. We draw a line under it. We go, here's our next one after it. If this one is less than 5, we don't have to do anything. We just get rid of all figures after the 3 that we're interested in. If it's more than 5, we have to add 1 to the last figure here. So in this case, we would add 1 to that last figure there. Then we would end up with 4.47. That's how we deal with rounding. Here we have the question asking us to factorize. That's taking out the common factor here. Now, x is not present in both terms, so x is going to stay on its own. But you can divide both 4 and 20 by 4. So you can take that 4, stick it outside the brackets, and then have x plus 5. Because if we expand those brackets, that will take us back here. This is a useful skill for some of our later maths where we need to do these sorts of things to make our problems easier to solve. For this question here, we have a lovely little triangle with 3 sides. To unpack this one, we need a bit of Pythagoras. Pythagoras is that rule that the 2 short sides each squared add up to this long side squared. This long side here is 10, so that long side squared is going to be 100. This side here is 6 meters, so we know that that side squared is going to be 36. So this side here, squared, is going to equal the long side minus this other short side. So that would give us 100 minus 36, which is 64, and we're looking for the square root of that to find the distance from here to here. That's going to be 8. Once we know that that's 8 meters, we effectively have 2 triangles here that are really the same size. A 6 meter high triangle with 8 meters on this side and 8 meters on that side. We remember that the area of a triangle is half the base times the height. So the area of this triangle is going to be a half 8 times 6. The area of this triangle is going to be a half 8 times 6. So if we add those together, what we end up with is really just 8 times 6, which is 48 meters squared because it's an area. Cool. Next question here. We have solve 2x plus 6 equals 96. First thing we might want to do there is group all the numbers on the same side. If we take 6 off both sides are still equal, so we end up with 2x is equal to 90. At that point, we know 2 lots of some number is equal to 90, so if we divide both sides by 2, we find that x is going to equal half of 90, which is 45. Converting 0.56 into a fraction, the way we do this is we remember how to convert our decimals into fractions. So 0.56 is the same as 56 over 100. Once you've done that, you can try and make it simpler. Maybe you divide it in half first, and that would get you 28 over 50. And then you find you can divide it by 2 again to get down to 14 over 25. 14 and 25 don't have any common factors other than 1, so that means this is our simplest form of fraction. List all the factors of 26, so we're looking for numbers that can be multiplied together to make 26. The easy one is 1 times 26. So both 1 and 26 are going to be factors because the number itself and the number 1 are always going to be factors of our numbers. If it was a prime number, those would be the only two. But if it's a composite number, a number that isn't a prime, then it's going to have some other numbers we can multiply together. Because this is an even number, we know it's divisible by 2, and that would give us 13. So 2 and 13 are both factors. If we go through our other numbers, we realize there's no other ones that can be multiplied together, leaving no remainder to make 26. So that's our full set of factors for 26. Here we have a nice question where we go into a store, our camera costs $15.50, and we want to figure out how much it costs with this discount of 15%. So if we're getting a discount of 15%, what percentage of the price are we really paying? Well, 100% would be the whole price, but we get 15% off. So really, we're paying 100 minus 15, or 85% of the base cost. 85% as a decimal is 0.85. And we remember that the word of in questions means times. So if we were looking for 1550 or 0.85 of 1550, we'd say 0.85 times 1550. And if we did that, we'd end up with $1,317.50. A lot of us weren't writing the extra zero here. Just remember that if it's money, we want to go down to 2 decimal places. Awesome. The next thing here is a nice little area question. So this one looks on the surface like it's going to be a bit tricky until we notice something nice. We've got these 2 parallel lines here. Imagine if we took this triangle here and we slid it over to this side. What you'd have is a rectangle. You'd have a rectangle with a side of 4 centimeters and a side length of 8 centimeters. How do we find the area of a rectangle? Well, it's base times height. And if we do base times height here, 8 times 4 is 32 centimeters squared. Squared because it's an area. Excellent. Let's move on to question 12 here. So this is another area question. It's going to take a little bit more to solve this one because we need to unpack each section. There's a couple of ways you could choose to do this one, but effectively you're looking to break it into nice chunks that you can solve. So the first thing that we might look at here is, it's not an area question, it's a perimeter question. This was something that a few of us got confused with, even I just got confused about it then. So to find the perimeter of something, remember we add up the lengths on the outside. So this one's just a bit of a red herring thrown in there. But the question is, do we need it to figure out this length here? Well, if we did interpret that we needed that to find this length here, then we would know that this squared is equal to, let's have a little bit of a look here. If I do it quickly on my calculator, I'll double check that when we wrote this down it was all good. 20.4 plus 31.2 plus 18 plus 14.4. No, so so what we're meaning here is that these 4 bits added together give us 84. Yeah, so we don't even need to do the fancy maths because that 31.2 is meaning the whole length across here. I was worried it just meant up to that point, but that's not what it means. So that's kind of a straightforward one with a little bit of trickery thrown in here to make it look more complicated than it really is. Okay, question 13, first probability question we've got here. So if we had these as little tiles and we put them in a bag and we grab them out, what's our chance of getting an A? Well, how many A's are there in mathematics? There's 2. How many total letters are there? There's 11. So you have 2 chances out of 11. So that's 2 over 11, or 2 divided by 11. If you wanted to write it as a decimal, that would be 0.18181818 going on forever, or 18.18 going on forever %. For this one here, we remember the angles inside a 4-sided shape should add up to 360 degrees. These 4-sided shapes are sometimes called quadrilaterals. So 110 plus 80 plus 85 all added up is going to be 85 off 360. So we know that this bit must be 85 degrees. This one here, we've got a regular pentagon. What that means is that all the sides are the same length, all the angles are the same length. The rule for angles in a regular polygon, any shape really, are that you count the number of sides, you take away 2, and you multiply that number by 180. That gets you the number in the middle. If you think about a triangle, the angles inside a triangle add up to 180 degrees. Well, there's 3 sides to a triangle. 3 minus 1 is 1. 3 minus 2 is 1. And 1 times 180 is 180. If we had a 4-sided shape, like a quadrilateral, like we were doing up here, we have 4 minus 2 times 180 is 360. So for a pentagon, you've got a 5-sided shape. 5 minus 2 is 3. 3 times 180 is 540. You've got 5 sides, so you've got to divide 540 by 5, and that should get you 108 degrees. Next question here, question 16. You've got to write a fraction that's equivalent to 4 over 7. So there could be any number of things, but essentially we wanted to make sure that you're multiplying both the top number and the bottom number. The easiest one, for example, is timesing both by 2, 8 over 14. But you could have had 12 over 21. That would have been fine too. There's a whole variety of other ones, providing both numbers were multiplied by the same amount. Right? They're equivalent, as in similar to. Angles on the outside of any shape always add to 360 degrees. So here you can imagine that you're walking along here, you're walking down here, you're walking back, you end up back where you started. So you've done one full rotation, so these all add up to 360. If we add these 3 together, we end up with 190 between those two. So 305 in the end. And so that's 55 off 360. So that angle is going to be 360 degrees. For question 18, we're asked to draw a straight line, this line using this equation here. If x is equal to 0, so as in we go on our x graph, we go along to 0, then we know y is going to equal, well, 3 times 0 is nothing, so y will equal minus 2. So when x is 0, y is down here, minus 2. That's the first point I'm drawing. Next thing is make x 1. Well, when x is 1, you've got 3 times 1, minus 2 is positive 1. So when x is 1, y is also 1. Same thing again, you'll notice it's going up. For each time we go across x by 1, we go up by 3. That's what that number there is, that's our gradient. So our gradient here is 3, so you can really kind of think about it. Each bar you go across in x, you go up by 3. So that should be the lining you end up with. Make sure you're drawing in those negatives as well. Here you got the perimeter of a square is 20 centimeters. What's its area? Well, there's 4 sides to a square of all the same size. 20 divided by 4 is 5 centimeters, so that square's side is 5 centimeters long. Its area, therefore, is going to be 5 times 5. 5 times 5 is 25, in this case 25 centimeters squared. Now on to the next page here, we've got question 20. So for question 20, you'll notice that the question talks about probability of pulling a red ball from a bag that only contains white and black balls. Well, if it only contains white and black balls, you can't pull a red ball. It's impossible. So we're writing 0 or 0 over 10 or you can't be done, all valid answers here. For this one here, we've got alternative angles as our nice fancy rule. You can imagine sliding this up to here, and it would be vertically opposite this side here. So as a result, x is equal to 113 degrees, the same as that one there. For this one, a number of us got a little bit confused about what standard form is. Standard form is the way that scientists in particular like to write really large or really small numbers. It can be quite helpful if you're only interested in a couple of digits to just kind of scale up or down in tens. The easiest way to do that is with 10 to the power of something. If I did 10 to the power of 2, then that would be 100, because 10 times 10 is 100. I'd have to, if I multiplied my number 1.48 by 100, I'd end up with 148. Here, though, you've got a really large number. So what we do is we count the number of zeros, and then we count all the way up to just before the first digit. and we say that's where our decimal point is going to go, and we'll write that out as this number 1.48 times 10 to the number of spaces we need to move it over. If you can imagine that decimal point hopping all the way up, it's going to need to hop 11 times for this to be valid, so it will be 10 to the power of 11. Lime scooters cost $1 to unlock, and then 30 cents for every minute. Well, in a 15-minute ride, it's going to be 15 times 30. Most of us got this bit. So 15 lots of 30 gives you $4.50, but then you've got to remember to add on the $1 to unlock. So that gets you a $5.50 cost. What are two numbers that multiply to give 18 and add to give 9? Well, let's look at the numbers that multiply to make 18. You got 1 and 18, you got 2 and 9, and you got 3 and 6. 1 and 18 adds to make 19. 2 and 9 adds to make 11. But 3 and 6 adds to make 9. So those are the two numbers we were after. For question 25, again, factorising, taking out the common factor. Notice there's a 12 in front of both of those, but there isn't a letter that we can take out here. So if we put the 12 out the front of the brackets, all of a sudden we have x plus y. Looks a lot cleaner this way. It can possibly be easier to solve some maths problems if this is our first step. Here we've got a two-parter. So a small fish tank has a base that's 60 centimetres by 40 centimetres. Fish tank's filled to a depth of 30 centimetres. The volume is going to be the depth times the width times the height, or times the length if you want to talk about it in terms of a fish tank. So 60 times 40 times 30 gets you 72,000 centimetres cubed because it's a volume. Now you're told 1 centimetre cubed equals 1 millilitre. 1,000 millilitres equals 1 litre. You're asked for the volume of water in litres. So this is going to be 72,000 millilitres. We know that 1,000 millilitres is a litre, so that's going to be 72 litres overall. If any of you have a fish tank at home, maybe that's something to have a look at. How many litres does your fish tank take? Think about it in terms of a milk bottle. That kind of makes about a bunch of sense, because you're essentially got numbers that are pretty close to half a metre across. It's going to be a lot of milk bottles to fill this thing up. Here we've got 84 centimetres split in a ratio of 3 to 1. So for every 1 centimetre here, you get 3 centimetres over here. Easiest way to do this is divide 84 by 4. That gets you 21. So one chunk is going to be here, and you're going to have 3 chunks of that size over here. So 3 times 21 is 63 centimetres. And we do this little colon here when we do ratios, so we don't get them confused with fractions. A rectangular postcard has a perimeter of 46 centimetres. If the height is 9 centimetres, what's the width? Well, we're trying to think about this. This is something that a few of us got confused with. But if the height is 9 centimetres, there's going to be 2 sides that are 9 centimetres long, and 2 sides with an unknown length. So if we were to write it algebraically, we'd say 46 is equal to 2 lots of some unknown length, x, plus 2 lots of 9. If we take away 18 from 46, 2 lots of 9, we end up with 28. And if we divide 28 by 2, because there's 2 sides that give us that total, that would get us 14 centimetres. What's the lowest common multiple of 6 and 8? Well, we're going to skip count in 6s and skip count in 8s and find the first one that matches. 6, 12, 18, 24, 30 is my 6s. Let's skip count 8s. 8, 16, 24. 24 is the first common multiple we come across, so that's our lowest common multiple. For this one here, it's a similar process. We're going to take our x's off both sides so that we have just one side with our x's. If we take an x off both sides, it's still going to be equal, so we'll have 4x on this side is equal to 28. So 4 lots of some number equals 28. Well, if we divide both sides by 4, we have x is equal to 28 divided by 4. X is equal to 7. All right, on to question 31. So for this one here, you can imagine taking this angle and sliding it up here. If you slid it up there, you would find that it overlapped perfectly. But we know this because those are parallel lines. This rule is called corresponding angles because they correspond to one another. So that angle there is 67 degrees. The highest common factor. So we'd list out the factors of 6 and then the factors of 24. And then we'd see which one was the largest. I'd start with 6's because 6 doesn't have as many factors as 24. So then you can just count along those factors and see which ones are and aren't factors of 24. What are the factors of 6? Well, you got 1 and 6, and you got 2 and 3. Is 1 a factor of 24? Yes. Is 2 a factor of 24? Yes. Is 3 a factor of 24? Yes. Is 6 a factor of 24? Yes, it is. And so the highest common factor between the two is going to be 6. Here you've got a circle of radius 6 centimeters. Now there's two little formulas that were given to us. They're given to us right at the end. Right at the end. So we flick down. Here we go. Our two useful formula. The circumference is equal to pi times the diameter, and the area is equal to pi r squared. So we might want to use one of these. Now I prefer using radiuses when I do these sorts of calculations, but you do you. So let's have a little bit of a look. So 2 pi r, 2 lots of the radius gives us the diameter, or in this case 12 times pi. Pi is about 3.14, so 3.14 times 12 gets you 37.7 centimeters. And for us, as long as you're using at least 2 significant figures, we're feeling okay. Normally, we'd like you to be presenting your answers up to 3 significant figures, please. Okay. For B, we're doing area, so we're doing the other one, pi r squared. So take the radius, multiply it by pi, square it, and then multiply it by pi. 6 squared is 36. 36 times pi gets us 113 centimeters squared. Nice. Expand and simplify. So for these ones, we need to expand our brackets. So take each value and crab claw, multiply it by the things in the brackets. So you've got x times x is x squared, x times 5 is 5x, 2 times x is 2x, and 2 times 5 is 10. Most commonly missed thing was 2 times 5. So here that would get us x squared, 5x and 2x is 7x, and 2 times 5 is 10. For this one, I would recommend that similar thing of you start with your negative numbers and you move towards the positives. So if we did 0 even, for example, 0 squared, 0 times 0 is 0. Take away 4, well when x equals 0, y equals negative 4. So we put our first point here. When x equals 1, 1 squared is 1, take away 4 is minus 3. So when x equals 1 here, y equals minus 3. Same when x is minus 1. Minus 1 squared is positive 1, positive 1 minus 4 is minus 3. So when x is negative 1, y is minus 3. When x is 2, 2 squared is 4, minus 4 is 0. When x is minus 2, it's the same thing. Notice we can plot those points in here. The key thing with this one was drawing in the curve and then making sure that we included the negatives in that as well. What two numbers multiply together to make 196? i.e. what's the square root of 196? That answer is 14. Chloe spends half her pay on clothes and 1/10 on a gift for her friend. She saves the rest. What fraction of her pay does she spend? Well, let's have a look. So a half, if we were to multiply this to an equivalent fraction that had the same denominator, the same bottom number here, we'd multiply it by 5. 5 over 10 is the same as 1 over 2. So 5/10 of her pay goes to clothes, and 1/10 goes on gift to her friend. She spends 6/10. Said another way, she spends 3/5. If she must save the rest, then it's got to be the leftover, 2/5. Awesome. Okay, on to the next question here. Halfway through, or getting close to halfway through. Here we're doing FOIL to expand our brackets. So first is x times x, that's x squared. Outside, x times 7, that's 7x. Inside, 4 times x, so you've got 4x and 7x, which makes 11x. And then 4 times 7, which is 28. So x squared plus 11x plus 28. The minimum wage is $21.20 an hour. How much would you earn if you worked for 4.5 hours? So this is assuming you get paid in 15-minute or 30-minute increments, which isn't unusual for certain jobs. So 21 times 4.5. Key thing here is half an hour is 0.5 hours. So 4.5 times 21.20 gets you $95.40, making sure we draw a 0 on the end. Expanding and simplifying, same FOIL system here. Here the trick is we've got a negative here, so we're going to have first x times x is x squared. Outside, x times minus 4 is minus 4x, plus 6 times x is 6x, so positive 6x minus 4x is positive 2x, and then 6 times the negative 4 is negative 24. So x squared plus 2x minus 24. The Black Ferns recently won the Rugby World Cup. How exciting! On the finals played at Eden Park, there were 42,579 people. How many is this to the nearest thousand? Now, a few of us, because I can understand, were like, well, it's, 421 away from the nearest thousand? And I get where you're coming from, but what we're meaning is rounding there to the nearest thousand. So we want you to go, okay, where's the thousands column? It's that 2-digit there. We're going to underline that. We're going to say our next one, is this greater or less than 5? It's greater. It's equal to or greater than. So we round up. That means we get rid of or replace these with zeros and add 1 to this digit here. So that makes it 43,000 people. Okay. For this one here, factorizing. So we're going backwards from our expanding that we did before. For this, we need to look at what two numbers add together to make 7 and multiply to make 10. Well, let's look at the numbers that multiply to make 10. We've got 1 and 10 and 2 and 5. 1 and 10 add to make 11, 2 and 5 add to make 7. So that's going to give us this bracket form, x plus 2 and x plus 5. We can double check it. If we expand this, x times x gives us x squared, x times 5 is 5x, 2 times x is 2x, 5x and 2x makes 7x, and 2 times 5 makes 10. So that's correct. For this one here, we're simplifying this. We notice that the denominator is the same, so we can just take this off this without having to worry. 6x minus 5x is 1x, or just x, because mathematicians are lazy. They don't like writing extra things if they can avoid it. That gets us 1x, or just x, over 7. Question 44. So for this one here, you're trying to solve for x. You're saying, what numbers can we make x so that this statement is true? Well, if we make either of these brackets equal to 0, then this will be true, because it'll be the whole bracket is 0 times anything else is 0. So what number minus 4 is equal to 0? Well, that's positive 4. And if we did that, 4 minus 4 would be 0. This whole thing would be true. X can also be a number here that would make this bracket equal to 0. In this case, minus 7. So x actually has two solutions, minus 7 and positive 4. And if we write those both down, we get the full marks. Factorizing again, here the trick is that we've got a negative. Because we've got a negative here, we know that we're going to have a plus side and a minus side. When we do that, we are looking for two numbers that multiply to make negative 8 and add to make positive 2. What numbers multiply to make negative 8? We've got minus 1 and 8. You've got minus 8 and 1. You've got minus 2 and 4 and minus 4 and 2. And those are our only options. So the question is, which of those combinations of numbers adds to make positive 2? The answer is positive 4 and minus 2. So that's what we write down. Here we've got Manani buying some exercise books. Buy one, get one half price. She needs 5. How much does it cost? Well, if she gets the first 2 books, she gets the second one half price. She gets the third and fourth book, she gets 2 half price, so she effectively gets 1 for free when she buys 3 books. And then the fifth one, because she's buying it on her own, she doesn't get a deal with that one. So she's kind of getting 4 books for the 5 books for the price of 4. So $2.30 times 4 is $9.20. For this one here, P, Q, and R are next door to each other. There's no plus symbol, so we assume it means multiply. Here we go, minus 1 times 3 times 4. Well, 3 times 4 is 12, times minus 1 is negative 12. And that's our answer. For question 48, you can imagine we're walking along here, we turn down this way, we turn at x, and we end up facing back where we came. These two angles equal 180 degrees, because we end up turned around if we were walking like that. So what number plus 119 equals 180? Well, that number is 61. Another way to phrase this is co-interior angles. These are both on the inside, so they are co-interior. They add to 180 degrees because they're on parallel lines. All right, on to question 49. Here we've got two sides. The trick here is this is 40 millimeters. So if we convert that to centimeters, remember millimeters are the tiny little dashes on the ruler. So 40 millimeters is 4 centimeters. 5 times 4 times a half, because we've got a triangle to find the area, and it's half base times height. So a half times 5 times 4 is 10 centimeters squared. For this one here, first step might be to add 3x to both sides. Let's do that. Add 3x to this side and that gets cancelled. You end up with 40 equals x plus 3x, or 4x. So 40 is equal to 4x. So therefore x is going to equal 40 divided by 4, which is 10. This one here was a bit tricky because you've got a semicircle here and then you've got this box. The area of the window, well, the area of the box is just going to be 40 times 40, which is 1600. A bunch of you were able to get that. The next thing you notice is that, well, the diameter of this box is 40. So the radius is going to be 20. It's going to be half that. So to figure out the area of a whole circle, we do pi r squared. Here, though, we only need half a circle. So it's a half pi r squared. So a half pi r squared is going to give us, I think, 430 centimeters. No, 630 centimeters. And we add that to our 1600, and that gets us 2230 centimeters squared. The perimeter of the window is a little bit different. We go 40 plus 40 plus 40. And the trick here is we've got half a circle's circumference. The circumference is 2 pi r, 2 pi radiuses, right? The radius is 20. A bunch of you used the whole diameter for this, which is where the mistakes came from. But if we did that, then that would get us a total perimeter of the window of 183 centimeters. For this one here, notice instead of having a number that's in both terms, we've got an x in both terms. So we can take out that common factor. We've got an x on the outside of the brackets, and then we've got x minus 6. Useful skill if you want to get rid of those squared terms, which can be a bit tricky. For question 53, we've got an isosceles triangle. Because this triangle is isosceles, this angle is going to be the same as this angle. So because this top bit is 38 degrees, we know that these two are going to be the same. We say, well, what's left over? Well, the leftover that's going to be split evenly amongst these two is going to be 142 degrees. And 142 divided by 2 is 71. So, and they've written here, isosceles triangle, base angles are equal because those two angles are going to be the same. For this one here, a little bit tricky. If we just solve this bracket on the right, well, it's going to be x is going to be equal to minus 3, because if x was minus 3, minus 3 plus 3 would be 0. This whole bracket would be 0. It doesn't matter what's in here, because that whole thing gets times by 0, and its statement is true. For this one, well, we're looking for a number that multiplied by 2, take away 7 equals 0. Well, if this was just x minus 7, then this would be positive 7. However, we're going to need to make it half that size because we're timesing it by 2. 7 divided by 2 is 3.5, or you could write it as a fraction, 7 over 2. So positive 3.5 or 7 over 2, and the other answer was minus 3. Here's some skyline prices for Rotorua. If we have a little bit of a look here, if there's 2 adults and 3 children, you add the price of 2 adults, 37 plus 37, and you add 3 lots of children, so 3 times 24. Add that all up, and that gets you 146. You go 146 minus 117, and that gets you the difference. That's how much you save. You save $29 by getting the family of 5 deal. Now this one was a little bit tricky. Upper quartiles, lower quartiles, these sorts of things we touched on briefly. First thing we need to do is order our numbers. So we get the lowest number, 12, then 16, then 23, then 29, then 33, then 47. Once we've written those out, we can notice the median is going to be right between the two middle numbers. the minimum is going to be the lowest number, the maximum is going to be the highest number. The quartiles are going to be the points in between, directly in between the median and the minimum and the median and the maximum, right? Where half the data is put on one side, half the data is put on the other side. So in this case, your second top number is going to be 33, and that is your upper quartile. That's the border between the top quartile and the upper middle quartile, right? So I can understand it's a bit confusing because I think some of us took it to mean the top quarter of our data, and we wrote 33 and 47. But what we're looking for is the value at which that changes, and that value is 33. Okay, so now we're on to question 57. Ricky's getting a small portable office floor for his back garden. Each of those carpet tiles covers 0.16 meters squared, and they come in packs of 20. So each pack is going to cover 20 times 0.16, which is 3.2 meters squared. You know that the rectangular office floor is 2.4 by 4.2. If you multiply those together, 2.4 by 4.2, you get 10.08 meters. So you've got to say how many times will our first number fit in our second number. The answer is 3 and a little bit, 3.15. Because you have to buy the packs in full, Ricky's going to need 4 packs. It also helps us to answer this question here. For question 2, we know the floor area is just over 10 meters, so he'll need model B as a heat pump. The GST here is 15%. How much is $250 plus GST? Well, we know that 100% is going to equal 250. So an extra 15% on top of that is going to be 115%. If we convert a percentage to a decimal, 115% is going to be 1.15, because 115% is 115 divided by 100, which is 1.15. So 250 times 1.15 gives us $287.50. The alternative way to figure this out is you figure out 15% of 250, which you do by going 0.125 of 250 times by 250, and then adding that back onto 250. But you save yourself an extra step by having the 1 in there the whole time. Decreasing 70 by 15%, well, the easiest way to go about that is to think about, well, 100% would be $70. We're going down by 15%, so what we're really doing is going 100 minus 15, we're going to 85% of the total. So 85% is 0.85. 0.85 times 70 is $59.50. The next question has these things 5 to the power of 3, 5 to the power of 4 being multiplied together. The reason why we're saying leave your answer here as a power of 5 is because there's a little trick that we're hopefully familiar with. If we have 5 to the power of 3 times 5 to the power of 4, we can add those exponents together. If that was a divided by symbol, you could subtract the exponents. So the answer there is 5 to the power of 7. For this bus timetable here, you've got an example of some maths in the real world. How long is the trip from Selwyn Heights to Rotorua Central Mall? Well, if we look here, Selwyn Heights 9:08, Rotorua Central Mall 9:27. What's the difference in time? It's 19 minutes. How long is one trip for the bus? So we're looking at start to finish. The idea is you go Selwyn Heights, Western Heights, Pleasant Heights, Ferry Springs, Rotorua Central Mall, Rotorua CBD, and then back round to Selwyn Heights. So that 9 a.m. bus becomes the 9:08 at Selwyn Heights. That's the loop. So how long does it take to go from here all the way back? The answer is 30 minutes. That's the difference between 8:38 and 9:08, and the difference between 9:08 and 9:38. Last thing here. Given the perimeter of the shape is 29 centimeters, find the value of x. Well, the perimeter is going to be this, plus this, plus this, plus this. When you add all the x's together, you get 1x, 2x, 3x's, 6 x's. When you add the numbers, you get 1, 4 is 5, plus 1 is 6, minus 7 is minus 1. So these 4 add to make 6x minus 1, and you know that that's equal to 29. If we add 1 to both sides, you end up with 6x is equal to 30. So 6 times some number equals 30. Well, if we divide both numbers by 6, we find that x is equal to 5 centimeters. For this one here, we've got another special trick that we need to be familiar with, and that's when we're dealing with exponents in brackets. So the other thing here is the way that things to the power of a half work. So when you've got exponents in brackets, you multiply them. So a half times 12 is 6, so that becomes to the power of 6. A lot of us got that. The second thing is, what happens if you had just 49 to the power of a half? Well, anything to the power of a half is effectively being square rooted. If I had 4 to the power of a half, it would be 2. If I had 9 to the power of a half, it would be 3. So in this case, 49 to the power of a half is 7. That gives us the total 7x to the power of 6. That brings us on to question 64. We're looking to find the missing number here. There's a couple of different ways to do this. Some students used trial and error to figure this one out. Some students tried to simplify it as best you can. If it were me, I probably would put these to the power of 12 and then see where we go from there. So if I make this an equivalent fraction to this one, and then bring it over to the other side, it might make it a bit easier. So here we go. Let's make this 12 on the denominator, so I need to times this both by 3, so that would be 3 over 12. So some fraction plus 3 over 12 equals 7 over 12. Well, if I take 3 over 12 off both sides, I know that 7 over 12 minus 3 over 12 is going to be 4 over 12. So this fraction is going to equal 4 over 12. 4 over 12 is equal to 1 over 3. They're equivalent fractions as well. So as a result, I know that the missing number here is 3. For this one here, a little bit tricky. So unfortunately, there was an error in the printing of this question. So this question, I believe, had a 3 on many of your test scripts here. And what that meant was that this wasn't solvable by this particular method because, yes, because we're looking for two numbers that multiply to make 15 and add together to make positive. In your case, it was 3, but if it was positive 2, those numbers would be positive 5 and negative 3, right? So that would make the x solutions minus 5 or positive 3. There is actually another way to do this, though. And that's using a thing called a quadratic formula that becomes more of a focus our next year's maths. The quadratic formula is useful when you have an expression in this form and you don't know the terms that you want to be putting in here. If you're interested in that, give it a bit of a Google. Beautiful little invention invented by Rene Descartes. As a way for unpacking formulas where it's not super easy to solve them like this. We awarded marks based on having a go at this one, even if you didn't get it 100% correct. For this one here, if you imagine you've got this rectangle with two sides, you've got it with an x plus 4 and you've got a 2x plus 3, well, the area is going to be those multiplied together. So you can kind of think about it like two brackets you've got to expand. So let's do FOIL. X times 2x is 2x squared. That's that part there. Next, the outsides, x and 3, well that's 3x, and 4 and 2x, that's 8x. 3x and 8x is 11x. And then 4 times 3 is 12. So the full expression should be 2x squared plus 11x plus 12. For question 67, we're asking you to substitute in some values here. So as we're substituting in these values, what we should find is that you have 3 times x, which is going to be minus 3 squared, minus 3 all squared is positive 9. Positive 9 times 3 is 27. Next up, you have minus 4 times negative 3 times 2. Negative 3 times 2 is negative 6. Negative 6 times negative 4 is actually positive 24. This was our biggest error here. When we add those two numbers together, we get a positive 51 as our result. Some of us accidentally missed this negative sign here. That's okay, just recognize it for next time. For this one here, we're looking for two values that will fit in for P and R that will make this true. The difficulty here was a few students saw this dot and they got a little bit confused. This is another way of writing a multiplication sign. So here you're looking for a number you're going to stick out the front that you're going to multiply the 5 by to get 15. Well, that's going to be a 3. The second thing is you're looking for, because remember when you're multiplying with exponents, they add. So here you've got an x to the power of 3, so therefore this r is going to be to the power of 7. So p was 3 and r was 7. Now for parabolas, we may or may not recall back to some things we worked on earlier in the year around tables, equations, and graphs. If we did that particular course, this was a very tricky question. That required us to recall what we call vertex form. That's a way of writing our equations so that we can move a parabola around the place. We'll remember that in this particular form, if we change this, we move the whole thing up and down. Because you think about it, if I add another 1 or 2 on this, I'm going to be increasing my y, increasing my height at every x value. Even if the x values remain the same, it gets taller. So this value here, if I change this, it moves things up and down. Here I'm trying to move things to the left or the right, or in this case the right. So the way we do that is by, instead of writing x, you write it in a bracket. And if I go minus 1, I'll shift every x value to the right by 1. If I make it minus 2, I shift every x value minus 2, as in to the right by 2 units. I'm trying to do it 3 times, so the full expression would be replacing this x with, in brackets, x minus 3, because I'm shifting every x value 3 units over, essentially happening 3 units earlier. That's kind of what we mean there. That gives us our full formula here. That was a very tricky one. This next trick here relies on 2 skills. The first is remembering that for negative numbers up here, it becomes 1 over this number to the power of this number. So if I had 2 to the power of negative 2, that would be 1 over 2 to the power of 2, or 1 over 2 times 2. Here we've got negative 6, so that's 1 over 2 to the power of 6. 2 to the power of 6 is 64. The only tricky bit here is you've got a negative here. So you've got to ask yourself, how many times am I timesing this number together? If it's an odd number of times, my result's going to be negative. If it's an even number of times, my result's going to be positive. And in this case, we're timesing negative numbers by itself 6 times. So as a result, we get 1 over positive 64. Now this one was a very tricky question because it had a lot of language skills in here. Find all the natural numbers, so we're looking for counting numbers, right? 20, 21, 22, 23. Inclusive, meaning we're also looking at 20 and 40 as potential numbers that could be here, that are composite numbers with exactly 6 factors. So a composite number is a number that is not a prime, right? So we'd go through and write out our list of numbers 20 to 40, and we'd immediately cross off anything we know that is a prime number. Once we crossed off the ones that are prime numbers, we're looking for ones with exactly 6 factors. So some of our numbers, like 21, don't have enough factors. Some of our other numbers, like 30, have too many factors. As we go through, we eventually can identify that there are 3 numbers that satisfy all these conditions. Those numbers are 20, 28, and 32. Bit of a tricky one there. For this question, let's rely on the skill of knowing that the three angles on the inside of a triangle add up to 180 degrees. So 180 is going to equal x plus x plus x plus 40 minus 10, or plus 30. So 3x plus 30 equals 180. If I take 30 off both sides, I end up with 3x equals 150. So what number times 3 equals 150? Well, if I divide 150 by 3, I get x equals 50 degrees. And that is our answer. For our final 2 pages, we're looking at some geometric rules. So this first one shows a line from the center of a circle to the tangent, or to a tangent at the edge of a circle. As soon as we have a tangent at the edge of a circle, that is always going to be at right angles to a line going straight up to the radius, straight up to the center point of the circle. So this angle here, x, is going to be 90 degrees at right angles to. For B, as soon as we see we've got a radius here and a radius here, they're touching the edge of a circle, and they're going to the center, we're going to know that these angles are going to be the same. Because this triangle is an isosceles triangle, because those lengths are the same, and therefore these angles will have to be the same. So that makes x 33 degrees here. For this one here, this is a neat little rule. If we haven't encountered this before, that's okay. This angle on the outside here, or at the center, is always twice as big as this angle on the outside. Picking any 2 points and drawing a little line to those. Neat little trick here. If we hadn't encountered that before, that's totally okay. But if we had, that was the rule we were trying to identify there. For D, if we ever get this sort of M shape inside or with 4 points touching a circle, interesting thing here, these two angles are the same. Reason being, they're on the same arc. You can imagine that we could sort of grab this point and drag it around the outside. As it moves around, that angle stays the exact same, no matter where you end up on that arc. In a special case, if these 2 points lie along a semicircle, this angle would be 90 degrees. So in this case, that angle is 39, so this angle is also 39. This one here, we know we walk 66 degrees this way, and then 23 degrees this way. So we know that this angle is going to be the inverse of those two added together, right? Another way to do it would be to draw a line out to here, and you could imagine trying to fill this in at that point. What you'd find is that this would equal those two angles. So 23 plus 66 is 89 degrees. Last one here. So 60 degrees here, well, that's going to make 60 here. This angle here is therefore going to equal 180 minus these two. The final step there is knowing that this angle here is going to be 180 minus that. So the quick, dirty way to do it is to add these two together and know immediately that is going to be our x. In this case, that makes it 125 degrees. And for the final question, we had a couple of very difficult ones involving some volume calculations. So for these questions, we even had a couple of 2 markers in here. The first thing was calculate the volume. Well, volume involves us figuring out the surface area on the front here and then multiplying it by this depth. So the surface area is going to be, well, a half base times height. A half of 1.3 times 1 times 1.8. That would give us the total volume here of 1.17 meters cubed. To figure out the surface area, well, we've got this side, we need to figure out the other side, our 3 prism sides as well. So I know that this is a half times 1 times 1.3, and I need to double that. So I could just go 1 times 1.3. That gives me those two faces that are triangles. To figure out the prisms, I need to go, well, I've got two sides here that are 1.8 times 1.2, and I've got one side here that's 1.3 meters by 1.8 meters. And if I add up all those bits together, you should get a total of 7.96 meters squared. For this one here, we have a circle shape, and we can refer to this rule down the bottom here to figure out the area of the top. The area of the top is going to be pi r squared, so the radius is 0.4. Pi times 0.4 squared gives us the overall radius on the top. We then multiply that by 1.2, and we should get about 0.6 meters cubed as the volume of the cylinder. To figure out the surface area, well, we've got the top and the bottom of the cylinder in terms of area with pi r squared. We just need to figure out what this shape is going to be like. If I was to unfurl this, I would have a rectangle with a height of 1.2 meters and a length that goes right the way around the circle. This length that goes right away around the circle, we call that the circumference. So if we can find the circumference of the circle, we can find the surface area. To do that, we take our 0.4 meters for our radius, and we multiply that by 2 pi, or 2 pi. So we're using the calculation 2 pi r is equal to the circumference of a circle. So 2 times pi times 0.4 would get us that distance there. We then multiply that by 1.2, and we add that to our top and bottom circles. Once you do that, you should get a little bit over 4 meters squared of surface area. And that was the last question. If you have any further partai about these assessments, if you feel like you've been marked incorrectly or we've miscounted those results, that's absolutely fine. Just let us know the next time you see us in class. Congratulations on getting through this. It's okay if we didn't get the mark that we wanted. The key thing is that we're improving our understanding over time. So if you're getting a better result now than you did previously, that's good. If you learned something new as we went through this, that's good too. Alright, thank you very much, team. Have a lovely rest of your day.